two solutions for the same x value. If this had been like a 1 over here, it would be plus or minus 1. So we'd have had 2 positive 1 and 2 negative 1 as x. So be careful of that. Same thing happens here when I plug in negative 2 squared plus y squared equals 4. That's going to be 4 plus y squared. Same thing happens. That's 4. My brain's doing the math first. So y is equal to 0 again. So we have negative 2, 0 is also an answer to that. 2, 0 and negative 2, 0 are answers to that. And those are the two answers. This didn't have 4. We just only had the 2. So the picture I drew was just a sketch. It wasn't the exact graphs of these. Obviously, they were either further apart or scooted down where they didn't run into each other. So those two are solutions to this. Okay. All right. So there's using elimination again, which is always a good method out of that. Let's go on to systems of inequalities, and then linear programming is the last things that we do. So this is section 5.6, and I'm going to swap to. I'm going to sketch some graphs here, so I'm going to swap over to some graph paper on my page, just so I can make my graphs a little bit more accurate. Hopefully. See that and stuff. So 5.6 systems of inequality. So I'm going to draw it by hand, and I'm also going to show you how we can do this a little bit with the calculator. Calculator is not as nice for this as we wish it was, but it still can do some shading for us, which is nice. So we can kind of get an idea of that. So let's start with example A. X is greater than 6 minus 2y, and then the other one is x squared is less than 2y. So we got two inequalities there, and we want to try to solve those. When you're solving systems of inequalities, the answer really is just the graph. There's not a single ordered pair that's the solution, or a no solution type situation. You've got to see the graph and where the shading occurs. The answer is where the shading overlaps for these. Okay, so we've got to work on shading and graphing these inequalities. So best thing to do is just get y by itself on all of them. Okay, so the first one, let's get y by itself. Subtract 6, so that'd be x minus 6 is greater than negative 2y, and then we would divide everybody by negative 2. And that's going to get us negative 1/2 x plus 3 is less than y. Don't forget the rule that if you divide or multiply by a negative with inequalities, that you have to flip that symbol. So that's why I flipped it around like that. Okay. Second one's a little easier to do. You just divide by 2. So that's just going to be 1/2 x squared. And I don't flip it on that one because I divided by a regular 2. A positive 2. I didn't divide by negative. So there I get y by itself. If it helps you to rewrite it where the y is on the left-hand side, this is what they would look like. Notice how it's still pointing toward the same things. Make sure if you rearrange it that you don't change that unless you really need to. Okay, so we've got two equations or inequalities that we need to graph here. So if I'm going to graph those, I'm going to graph it by hand, and I'm going to show you what it looks like on the calculator to make it do the shading and all that fun stuff without using an app. I know some of you may know that there's an app on your calculator, or some of the calculators that do that, but I can't in good conscience show you that, so I'm not going to, because you're not supposed to use it actually. So next thing you're Googling is how to do the inequalities on the graphic calculator, but that's okay. So I'm going to graph these. I'm going to graph the linear equation first. It has a y-intercept of 3 and a slope of -1/2. And it's a dotted line because it doesn't have an equal to mark. You remember that for Math 100? I believe is where we did these inequalities. And then I need to shade that. So I need to decide, do I shade above that line or below that line? So if I plug in 0, 0, the original, the origin there, and then so 1/2 times 0, 0 plus 3, is 3 less than 0? No, it's not. So I would shade away from the origin. So I would shade the top half of that one. So I would shade up here. So I'm going to use a highlighter because it works real well with this. So I'm going to shade that half of that line. And then I'm going to graph y is greater than 1/2 x. I know that's a parabola that has a vertex at the origin. Basically, to get the rest of the graph, I'm picking x values and plugging them in. So 1 squared is 1, 1 times 1/2, 1/2. So at 1, we're at 1/2. At -1, I'm at 1/2. At 2, 2 squared is 4. Half of 4 is 2. And same thing happens at -2. If I go to 3, 3 squared is 9. Half of 9 is 4.5. 3, 4.5. If I go to, that gets me a pretty good idea of that picture. It doesn't have an equal to mark, so I know it's a dotted line or a dashed line. So the parabola is going to look something like this. The shading for that, it's either the inside of the parabola or the outside of the parabola. I cannot check with the origin because it's on it. Okay, so I need to check either the inside of the parabola or the outside. I'm going to check the inside. So I'm going to pick 0, 1 and plug that in for x and y. X is 0. 0 squared times 1/2 will be 0. Y was 1 because I'm testing 0, 1. Is 1 greater than 0? Yes, always. So I'm going to shade the inside of that. If it had been false, I'd shade the outside of the parabola. I'm going to shade the inside of that parabola.
How did you know where to cross in your edge?
Right here. For the parabola.
The 6, is that what it is? Yeah.
I just did my slope down, down 1/2, and I just kept going. Okay. You could pick x values if you wanted to for that and get it. Notice where it turns green. That overlap there that's the solution area. So all of these ordered pairs in this overlap, that's the solution area out of that. This whole graph is the answer. It's not one ordered pair out of it. It's all of those ordered pairs in the green area. Okay. So with the graphing calculator, one of the limitations you're stuck with is that you got to have y by itself for it to graph things. Okay, so you got to get y by itself every time. So if I go to the y equals menu, I'm going to clear out some stuff that I had some reason put in there. I'm going to get y by itself. I'm going to do the linear one, which was y is -1/2 x plus 3. And then the quadratic was 1/2 x squared. And I'm gonna look at the graph there, and we see that the same bones of it. Now we need to do the shading part. Okay, the shading part, you still got to know which side to shade. Okay, and so if you hit y equals and then press the left arrow key, if you got one of the color ones and hit enter, it's going to come up with this menu thing, and you would select line. Just press the right arrow key. If it's greater than, you're going to pick this one. If y is greater than the -1/2 x plus 3, which our equation was that. So I would pick that upper triangle because you're going to shade above that line. Remember we checked that? And then, so I would then hit OK. And then the other one, I'm shading above the inside of that graph. So I'm going to hit enter there, go down and press that, and I'm going to get the one that's above again. And then click OK, and then hit graph, and we're going to see the shading happen. And that's exactly what I drew there. You still got to know which side to shade to do that. If you've got the black and white version, the difference is, I think I can change mine to the other emulator, I think. Somehow. There it is. Yeah, thank you. That's what I was looking for. Couldn't find it. All right, so here I'm on the black and white model, and you don't have that menu thing where it tells you what color it's going to be and all that. So you got -1/2, whoops, divided by 2, x plus 3. You would press the left arrow key and still get over there to the left where that line is, and if you hit enter, it changes what picture is there. You still want that triangle to the top half if it's greater than. If it's less than, you're going to go the triangle to the bottom half. Just press enter until you get that going on, and then when you graph that, it still does the shading for that. Same thing when you go to y2, you've got 1/2 x squared, and then I'm going to press the left arrow key, get over there, hit enter until I get the triangle above because it's greater than. Again, if it's less than, I'm going to get the triangle below, which would just be enter again, you'd get the below. So I'm just going to hit enter until I get back to that triangle above. Graph. And there we see, it's not quite as pretty on the black and white version, but it still does the word. You can still tell where that shading is out of that. And again, that graph is going to be the solution for that, not that's what it is. So, all right, let's look at another system here. That could be, let's take y is greater than or equal to the absolute value of x plus 1, and then let's say y is less than or equal or less than 4x plus 3. So that's our system that we're going to graph. Luckily, y is by itself already on both of them, so that makes this a little quicker and easier. Okay, if I'm gonna graph it by hand first, and then we'll do the calculator. Since y is already by itself, I don't have to do any work to get it there. So I'm just going to go ahead and give myself a little bit more room up top because I know that's where everything's happening at. What's the absolute value graph look like? Y'all remember? It's been a while since we did that. A V. That's exactly right. Absolute value graphs look like a V. Okay. This one is going to be centered at 0, 1. Should be right there. I'm going to change color, do a red color on that one. And the slope would be up 1/1. I could find all that stuff by just picking x values and plugging them in. If I plug in 1, absolute value of that is 1 plus 1 is 2. So I know that that's here. If I plug in -1, I get the same thing. And it just keeps going that direction. As I plug in x values, I can get that picture. And it's that V shape. So absolute value graphs have that V shape. Just general, always going to look like that. All right. Now the shading needs to occur. I put solid lines because that's an equal to mark on that. Anytime it's got equal to marks, solid lines. If it doesn't have an equal to mark, it's a dashed line. Now I need to shade that. So I'm going to pick a test point. Can I test the origin? Does the graph touch it? No, so I can test it. If the graph doesn't touch the point, I can use it. Okay, that's the rules. Okay, so if I plug in 0, 0, is 0 greater than the absolute value of 0 plus 1? 0 is bigger than 1? No. So it's false out here. So that means I'm going to shade above that which would be the inside of that absolute value V. Let me fix that a little bit. So all of this area and extending on to infinity there inside of that V shape are the solutions to the first inequality. Now let's graph the second inequality, which I'll graph it with a green line. It's a linear equation, so that's something we know about graphing. What's the y-intercept? It's 3. So I'm going to put a dot there. The slope is 4. So I'm going to go up 4 over 1. I could do that again if I wanted to. I could go down 4, left 1 if I wanted to. But I get a line, and it's dotted because I don't have an equal to mark. Yeah, I just did the slope to get those. If you want to plug in x values, by all means, you can do that to get the graphs. Plugging in x values will always get you a graph, no matter what kind of equation you have. Now we need to do the shading. 0, 0 is not touched by the green line, so I can test with that. Is 0 less than 3? Yeah, so that means I'm going to shade this direction with this line. So I'm going to, and we see the overlap there is the green shaded area. That is the solution area to that problem. With the graphing calculator, I'll do the black and white version first this time. I'm going to get the absolute value. So absolute value is math, and then go over to number, and the first choice is ABS. That's absolute value. And then it's X, and I'm going to press the right arrow key to get out of there because it was absolute value of X plus 1. I know that I'm going to shade above that because it's a greater than symbol. So I'm just going to press the left arrow key until I get over there and make it turn into the triangle above it. Okay. The second equation is going to be, what was it? 4x plus 3. Okay. So I'm going to type in 4x plus 3. 4x plus 3. And then I'm going to go over there and I'm going to shade below that one because it's a less than symbol. Y is less than 4x plus 3. Yeah, that's the right thing. So press enter until I get the triangle that's on the bottom left. There's the top right. There's the bottom left. Hit graph. Yeehaw. Okay. If you go to the newest of graphing calculators, you got absolute value, same location, math over to number, absolute value of X plus 1. And then this one is going to be 4x plus 3. And I need to change that to the triangle below. So hit enter, go over to line, the triangle below. And we see that same picture, just in color. Not too bad there. All right. It doesn't either the thick line or there's the solid line there. It doesn't matter. It doesn't matter which one you change it back to. The good thing, I don't know if you guys that have the black and white one, if you hit clear on it, does it automatically reset it to the original? If you go to y equals and hit clear on one of the equations. I think that's just an emulator thing because when I was hitting clear there, it was resetting it. That I don't think you're handheld to do that, which would be a neat feature. Unfortunately, they're not updating the black and white ones anymore. So The color ones have taken over the market. The price is not much difference on them now if you go buy them. The used market is just flooded with black and white ones at the moment. So. All right. Systems of inequalities. The graph is the answer. That's what you got to know. Okay. Now, last thing of the semester. Hallelujah. 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 All right, here we go. All right. All right. Two more examples. We're done. Okay. So the last thing is linear programming, is what it's called. I'm not too tough on you on the linear programming part. If you were in my college algebra class, Math 140, I would require you to be able to build the inequalities that you need and graph all of those and then find all of these other things. So I don't do that with this course just because I don't think it helps you learn anything. It just tortures 140 students. But no, it's actually not that hard. It's just kind of time consuming. And if you don't get those right, you can't get the final answer right anyway. So what I do is with linear programming is I give you what's called the objective function. And for this first one, let's make it 3x minus y. An objective function is what you're testing with. Okay, so maybe in parentheses there, this is your testing function. Right. That objective function, in the context of these problems, you're either going to maximize or minimize that objective function. What you're going to maximize or minimize it with is a graph of several inequalities. And that graph of all these inequalities, I will go ahead and give you. All right. The graph will be a polygon of some shape. And it'll have some ordered pairs labeled on it. And they may or may not necessarily be at the right spot. So I'm just going to kind of eyeball this here. That ordered pair at that corner is 6, 6. And they would have shaded all this in. So this is a colored in polygon. What these are constraints, is what they're called. In a business application of this, you would take all these constraints based on production models, or maybe it's stocks and stock market investments and things like that. And we're trying to maximize an objective function, which would be like if I put this many dollars in this mutual fund and this many dollars in another mutual fund, what's the maximum amount of profit I can make out of that? So that's what the objective function is. It's your profit function, or maybe it's a earned income function or something like that. That's the idea for a revenue function, but it's an objective function. What you're going to do with that is you're going to take the ordered pairs from the corners of your polygon and plug them in for x and y in the objective function and work it out. Okay? So for this one, maximize 3x minus y. So we're going to take each ordered pair, 1, 0. So what I like to do is just make a little table. 1, 0, and then I got 3x minus y, and then I'm going to put the value out here. So at 1, 0, I'm taking 3 times 1 minus 0. That's 3, right? And then I would take 1, 7. And it doesn't matter what order you do these in. 3 minus 7 is negative 4. And then I'm going to take 6, 6. 3 times 6 minus 6. It'd be 12. And then I'm going to take 8, 2. 3 times 8 minus 2. 24 minus 2 is 22. The maximum is at 8, 2 with a value of 22. That's what our answer is. It asks us to maximize it. We're going to find the biggest one. What do you find if you ask you to minimize it? It is that easy, okay? And so I will give you that graph. I will give you those ordered pairs. All you've got to do is apply it to the objective function out of that. Okay? Let's do one more. Say we have a graph, and I'm just going to sketch this one roughly. I'm not even going to draw it straight. 310, 513, 7.5, and 11.7. Those are the corners of my polygon. And this is a 4-sided polygon. They could have an infinite number of sides to it, depending on how many constraints that were used to make it. And our objective function is 2x plus 5y. Minimize the objective. And again, that objective function will be given to you, and you'll be, it may say like revenue function, maximize, minimize it. You see those words, maximize, minimize, you know that function is what you're plugging into. And again, I think making the table makes it easier. I mean, no doubt, just because it organizes things out of that. And then there will be some problems where it may ask you for both the maximize and minimize it, both. And having that table there can kind of help you do that. So ordered pairs in the left column, 310, 7.5, 513. Again, it doesn't matter what order you do them in. So 2 times 3 plus 5 times 10, 56. 2 times 7 plus 5 times 5. 14 plus 25, 39. 2 times 5 plus 5 times 13. 10 plus 65, 75. And then 2 times 11 plus 5 times 7. 22 plus 35, 57. And if we're minimizing that, then that's going to be right there. The lowest number is 39. So minimum of 39 at 7.5. That's another way to write the answer there. They change it up from time to time how they write it. So I just want to show you both ways there. But again, on your Canvas quiz, on the test, and if there's one on the final like this, and not always one like that, I'll go ahead and I'll skip to that problem, and I might draw the graph up here on the board for you. That I will find so that you can see that. So pretty straightforward out of that. The Canvas quiz, shortest one of the semester for this week. It's only got 10 questions on it. Not a ton of stuff, but it's got nonlinear systems, inequalities, and then objective function stuff. Things you'll get this week. You'll get a review for the test, which is next week for last regular test. You will also get a practice final. I'll go ahead and send that to you. You can start working on it and get, so that you're not just swamped next week. Because I know you'll have, some of you'll have more finals than mine. And you may have projects and things that you gotta do. So I'm gonna go ahead and send you those two things this week. And then you got your Canvas quiz to do. And we'll have labs at the beginning of the class next week and a test. And then, final exam is April the 29th, 2 weeks from today.
Are there
At normal time, 5:45.
any problem with the gestures?
Yes, let me write those up there. Sorry, I got sidetracked. 5, 9 through 42 is good set. 5, 6, 29 through 74. So that gets you a little bit of all of those. So just, I would suggest odd ones on those. So that'll get you going. You guys have a good week. Email me if you got questions. If you run into issues, I'll try to remember to post a link to the videos on there I'll send the documents to you. Okay. I'm ready.
So I gotta go back. You said that's at YouTube.
Yeah,
That's what I got.